Alright, looking good. Let's make this thing. First, create a fresh project and enable the water and landmass plugins. Restart the engine, and let's get started. The first thing you'll need to do is add a water body collision profile. The engine will remind you about that with this message log here. Just click the add entry and the engine will automatically create it for you. Clear the message and close it out. Create a new level, name it whatever you want, and save and open it. Open up the environment light mixer to add in the essentials. And with that done, create a decently large landscape. About 2K should be a good size. Don't worry too much about the settings. We just need a place to put our ocean in. Now drop in your ocean. Shrink the land island so we get more area to work with, and let's get in on our buoyancy. Add a new folder to hold our stuff and create a new blueprint pawn. I'm going to call it BA Dev Ship BP. And open it up so we can start adding in our components. First thing we're going to add is a static mesh. Load in an engine default cube and enable physics. Lower the center of mass in the Z to give our cube a little extra balance. We'll mess with some of these other settings later, but for now let's move on and add a buoyancy component. Add a pontoon and save the blueprint. Add our new shipment to the level so we can see if things are working. But it won't work immediately yet. We still need to add the water body collision the engine warned us about at the start. Select the ocean, move down to the collision presets, and select the water body collision option. Now if we simulate it again, it still won't work because I messed up somewhere. Make sure to move your static mesh into the default scene route to make sure things are working properly, and now click save and play. Now we've got our ship floating, but we need to get it moving. Fortunately, this part is actually pretty easy. Just copy and paste the movement over from the third person character. and connect our event play node. And now, before anything else, we need to make sure our ship is possessed on play so we can control it. Now, if we press play, you'll see things from the perspective of the cube. So we'll need to add some camera controls in there too. First off, go back into the third person character blueprint and we will copy over the camera and arm setup. Things didn't move over exactly as they should have, so just drag down the camera into the spring arm. Move the socket offset up on the Z and extend the arm length further back to about 1000. That should give us a better view of our cube, and that is indeed much better. Now we can view our ship in all its glory. We still need to make it move though, and as you may have noticed, our movement isn't working yet. First, delete the movement input nodes so we can add our own form of movement instead. But not in the third person character though, I forgot which blueprint I was in. Now in our actual ship blueprint. Just delete this over here, no real reason to keep it. What we'll use instead is an add force at location local. Moving things around a little. And what we're going to take is the action value y and multiply it to get our forwards pushing force. Split the force input pin since we're only going to be pushing in one direction and plug into the x-axis. Make the multiplier around 90k, physics really need those big numbers to get going. Now if you move back over and give it a playtest, you can see we are now sailing. And spin. Pretty funny, but not the realistic quadruple A sailing we're going for. First, let's lower the force we use down to something like 50k. And now let's add steering to our ship. Get an actor world rotation node and split the pin. Get the X value and add a multiply node. Hold on a bit while I do a little more reshuffling. Alright, now take the multiply and plug it into the delta rotation Z. Now this time for the multiply, we're going to use 0.1 to start. Turning's a little slow, so we're going to increase that value to 0.2. Alright, now we're turning a bit faster. Alright, now that's a bit better. Now we can use A and D to rotate left and right and push W to move forward. Alright, that's it for a cube here. Let's add in our actual ship. Alright, my ship's been imported. Now grab yours and use it to replace the default cube we've been using. Now before we give it a playtest, let's pull back the camera a bit since the ship's a little bigger than the cube. Of course, don't expect much yet because it will immediately tip over and go belly up. This is due to trying to balance the entire ship on our single pontoon that we created at the start. So what we're going to do now is make it a total of 6 pontoons instead. But before we do, I'm going to create some sockets on our ship mesh to attach our pontoons to. Open up the mesh and create our first socket. I'm going to call it front left. Continue doing this for 6 times depending on the size of your ship. And once you're done, copy the socket names over to your new pontoons. And with that done, give it a playtest to see if it works. Well, unfortunately, it seems something about using the mesh sockets caused a rather violent buoyancy reaction. I don't fully understand why this happened, but for now I moved the pontoon location data over from the sockets to the pontoons themselves, and everything now works fine. As you can see, this is a little more along the lines of what was expected. The ship still tips over, but that's easy enough to fix once we start tweaking our physics and buoyancy values. Alright, let's fix our balancing issues. Move over to our static mesh and lower the center of mass down to about negative 250. Also increase both the linear and angular damping. If you are unaware of what damping does, it acts as a sort of resistance against change. That will not only help balance the ship against forces, but also improve the weighty feel of our massive and heavy vessel. The next thing we'll need to do is enable our drag forces in water. These are a lot like the physics dampenings from earlier, but only with water interactions. Let's leave them as is for now and give it a playtest. Right, now the balance has been restored to our ship and it's not tipping over. But it also looks a lot more floaty than our big ship should look. Increase the mass a little and also increase the buoyancy coefficient to compensate for that. A little better, but you'll notice a problem has occurred. Our newly added forces are also preventing us from moving forward, so we'll need to fix that. Decrease the drag coefficient, and then increase the force of movement to see if that's enough. Well, we're moving, but in the wrong direction. This is because the forward axis of our imported ship was in the wrong direction. Ideally, you'll want to re-import your ship facing the correct direction, but for now we'll just address this by making the forward force negative. We'll also make our number a little bigger. Now we've got our movement down, but the ship's tilting in some strange ways. Up the angular damping a bit, and then add a little more to the buoyancy angular drag. Next, increase the buoyancy damp 1 and 2. We'll double damp 2 and raise damp 1 to 4K. A lot of this is about getting the right feel for the weight and size of your ship, so keep trying different values. I'm also raising the pontoons a bit to let the ship rest in the water a bit lower. Alright, that's enough of that. We still need to cover fluid sim and water materials. Select our ocean and scroll down to the water material. Click on the folder button to head straight down to the water content folder, and then move over to the fluid simulation folder. Now normally the fluid sim BP is intended to be added to the level and then enabled to follow the player, but unfortunately I found this to be rather buggy and sometimes non-functional at all. So what I've been doing instead is adding the fluid sim BP to our ship BP as a child. Why this works but the correct method doesn't, I don't understand, but I guess that's just the nature of working with experimental features. Now enable show simulation mesh so we can see what we're working with. Also increase the area size of the simulation so it can fully cover the area around the ship. Also slightly increase the resolution. Disable follow player since we don't need it in this instance, and let's ignore foam for now. Now head into the examples folder and grab the dynamic force component. And just like the fluid sim, we'll be adding this to the ship EP. Open up the default tab and enable show mesh. Increase the radius of our component to match the size of our ship. And now duplicate the component a couple times to cover the length of the ship. Place them wherever you feel will look right for ripples to appear from. Remember to disable the show mesh option on our fluid sim, and let's give this a try. The one in the back looks good, but the front ones look like they could be lowered a little more. Continue adjusting until you're constantly getting ripples from each one. Now we're also getting a bit of an issue here where the ripples are turning into tall waves, and we need to fix that. Head down into our fluid sim and open up the simulation tab. Increase the dampening to around 0.1 or sometimes 0.15. And then head over to our force component and increase our force strength. How this works is that increasing our dampening causes our ripples to lose strength faster. This will prevent the ripple buildup, but it will also need to increase the starting strength of our forces to make sure they don't disappear entirely. The ripples are looking a bit better now, but our ship's tilting again. Alright, we could continue fine tuning, but we need to move on to the water materials. Move over to the material folder. The correct material folder, that is. Grab the master water material and copy that over to your project's content. Always remember that changing something in the engine folders affects all projects using that engine version. Create an instance of your newly copied master material and name them both. Now select your ocean and replace the water material with your new one. Alright, open up the material instance and let's start adjusting some settings. First thing we're going to enable is caustics for some additional visuals on our water. Waves are already enabled by default, so that's fine. The things that we will change are color absorption, we'll lower the alpha to darken the water, and I'll also adjust the scattering. I don't think much else needs changing in this department for now, so let's change our focus to the waves. As you can see right now, our wave displacement fades out very quickly, forming a sort of ring around our ship. This is alright if you're on the shore and looking at the sea from a low perspective, But from our ship, having the sea flatten out so closely ruins the illusion of an open ocean. So what we're going to need to adjust is the distant normal length and distant normal offset. Normal length will affect the fade out of the waves. As you can see, the waves now fade out over a longer distance. And the normal offset affects at which point the fade out begins. Now for the waves themselves, select your water body ocean and click on water source. From here you can choose an already created wave asset or use the wave generator to directly define your waves. What we're going to use, however, is the wave asset, with the main benefit of being easier to save and reuse. Right click, go down to water and create water waves. Now load the wave asset into the wave asset reference and open it up. Now you'll notice we do have a slight issue with our new waves. The peaks are turning in on themselves as a result of being too steep. That's easy enough to fix with your steepness settings down here. And the rest of the values here are pretty self-explanatory. Wave length affects how wide your waves are, amplitude affects how tall your waves are, and direction is the wind angle. Fall off is also what you can use to affect the ratio of small waves to large waves, or short waves to tall waves. For now, just play around with your settings until you get the ocean surface you want. However, keep in mind you're also going to need to put in more effort on balancing your ship when using taller waves, otherwise you'll end up tilting over. Alright, now the next thing we'll need to address is the water going through our boat. We don't want our boat filled up with water while we're sailing. What you're going to want to do here is create a simple closed geometry in the shape of your ship. I've already created one over here out of a simple cylinder. Just go ahead and drag it over into your ship EP. It's not correctly oriented though, so I'll need to rotate it a bit. Once that's done, head down to the rendering and open the advanced tab. You'll need to enable visible only in scene capture. This will hide it from being seen in game, but will allow you to use the shape for things like water masking. To actually use the water masking though, you'll need to open up your water master material and head into the water opacity mask function. Once here, add a distance to your surface node and then add it to your existing mask alpha. With that done, the water will now stay out of the area defined by that cylinder. And that is the main gist of it. Rivers and lakes also follow the same workflow with some minor differences, but you now know how to set sail in Unreal Engine 5. Of course, there is one thing that should be mentioned, is that as of 5.3 or perhaps even earlier, foam is no longer working as it should. Instead, you will get moments like these. Well, that's not what I wanted. But that's just the nature of working with experimental features. Fortunately, you can still add these sort of features yourself by following some excellent videos here on YouTube. But hopefully we'll see the water plugin gaining updates sometime in the near future. Alright, that's all for now. I have plans for a landscape creation video later, and if this video picks up enough traction, I'll probably make a follow-up around ship combat.